Let me check. About question number 2. Now in this case, find the area. It says find the area of the surface x square divided to the z square equal to a square. Inside the surface, this. Now inside the surface, this. Okay. So question number 2 here, we are given the surface area of the surface. To find area of the surface, this is x square plus y square plus z square equal to a square. So if z equal to 0, if I substitute, then x square by equal to a square. This is the projected site or projected area. Okay, so inside the surface, this, let me inside the surface. So inside the surface of this curve, okay, surface of this curve, inside the surface, inside, this is inside here, I'm sorry, inside the surface of x square plus y square, which is whole square, equal to a square into x square minus y square. Alright, now in this case we have to substitute, or if I convert this into polar coordinates, but let me first write what is the del z del x and del z del y. Differentiating first equation, this is the first equation here. Okay, so from first one, z square equal to a square minus x square minus y square. Del z upon del x, if I find out, differentiating it, this is first equation, differentiating it, or first partially with respect to x and y respectively. With respect to x and y respectively. So first twice z into del z del x is equal to, this is minus twice x only. That's a 0. A constant, y is also considered constant. Therefore, this implies that del z upon del x equal to minus x upon z. Similarly, del z upon del y equal to minus y upon z. Okay, therefore, let me find out second alpha here. So second alpha, therefore, under root 1 plus, this is del z upon del x whole square plus del z upon del y whole square. That means under root, this is again 1 plus x square upon z square plus y square upon z square. That means in the under the, if I take z square LCM, it will be z square plus x square plus y square divided by z square here. What is this? Z square plus x square equal to a square. So this is a upon z square. Z square is that value under root a square minus x square plus y square. This is the value of second alpha. This we have to substitute. And now if I substitute x and into polar coordinates, if I substitute x equal to, okay, in parametric form, so x equal to r cos theta, y equal to r sin theta. In that situation, this is r square, a square minus r square it will be. Okay, so let me now integrate this. This is question number 2. So converting that into polar, so what is the projected line, or that inside the surface, it says inside the surface, that, so if I convert this into, this is r square whole square, r square equal to, this is a square into x square is, let me convert that into polar coordinates. This will give us, converting this into polar, putting, let me write x equal to r cos theta and y equal to r sin theta in this situation. This is r square, the second equation. So from second we get this one, x square plus y square r square here. By squaring these two, we will just square them and add them. So r square into cos square theta plus sin square theta, that means 1. So here x square plus y square will be equal to r square, because squaring this third equation, okay, and fourth equation, squaring and adding x square plus y square equal to r square cos square theta plus r square sin square theta. If I take r square common, then sin square plus cos square is 1. That is x square plus y square equal to r square. Okay, this is the value here. So this is r square whole square, this value equal to a square into this is r square, because x square is cos square r square cos square, this one, cos square theta minus sin square theta, it will be, so 1 r square is cancelled out. That means r square equal to a square into this is nothing but cos 2 theta. Because we know that what is cos square theta minus sin square theta, cos 2 theta. This is equal to, therefore r is equal to a under root cos 2 theta. This is value of r here. R equal to a2, and okay, and if I put the limits here, r equal to 0 to a under root cos 2 theta, that we will substitute in place of r. Okay, so limits for r are there, and z equal to, then z square equal to a square minus r square in this case. Okay, now let me first substitute the values of these. This is r equal to a under root cos 2 theta. Therefore, area of the surface, let me find out inside the surface. Inside the surface means, for that limits we will take from these equations. Okay, so let me take the area. Therefore, area of the surface. Therefore, area of the surface. Area of the surface, this projected on this or on this area. Area of the surface given is equal to double integration. Okay, limits are just choose about or take about r equal to 0 to this value, r equal to 0 to, this is a under root cos 2 theta, that we take here value of r. Okay, now first, what is the cos 2 theta we just calculated? It was a upon under root a square minus r square, because x square plus y square is r square, into r d theta dr into r d theta dr now. Okay, so this is r upon under root a square minus this. Let me integrate this. Now limits for this theta is 0 to pi by 2 here. Why 0 to 2 or 0 to pi by 2? Because in this case, if I put nothing is given, okay, that point is there. So x square by square equal to r square. That is the point here. Limits for this we have to take here 0 to pi by 2. Why? Because this, now in this case, this is the loop type. Okay, this is r equal to this r square equal to a square into cos 2 theta. What is this? Because cos 2 theta is a, if I put r equal to 0, then cos 2 theta equal to 0, that means theta equal to pi by 4. So this is 0 to pi by 4. If I take one arc and the area or minus pi by 4, 2 plus 5, put this area of the one loop, it will represent a loop here. Okay, so it will give us a loop. Area of the loop will be, okay, so 0 to pi by 4 limits we have to take, because theta in this case will be 0 to pi by 4. Why? Because in this case we have to take the loops of this area. Okay, so that will give us 0 to pi by 4. Why? Because cos 2 theta is, this is the area of the loop here. So this cos 2 theta, if I put r equal to 0, then cos 2 theta equal to 0. Cos 2 theta equal to cos pi by 2. That means 2 theta equal to plus minus pi by 2, or theta equal to pi by 4. Plus 1 pi equal, this we have done number of times. So this is theta equal to pi by 4. Now here we are taking the area of from 0 to pi by 4. I mean the upper portion of the first quadrant we have to take. In that situation, this is theta equal to 0 to pi by 4 here. Now r equal to 0 to a cos 2 theta, this is okay. Okay. R d theta dr, this is there. Now let me integrate. What is the area of the surface? Now it says find the area of the surface, this inside the surface, that value. Okay, so inside the surface, now this surface was the loop of this kind. First loop was this one, pi by 4, this one, and this loop was also there. So take only this loop. If I take both the loops, then this is twice of this. Okay, but in this case we have to take only this loop here, and these are the tangents. Within these two tangents, here theta equal to pi by 4, here theta equal to 0, so 0 to pi by 4. We take only because this area we have to find out. In this case, we take the P point, projection is upon this. Okay, so in this situation, this projection will give us the area. So one area either of this or this we have to calculate. Theta to pi 4 limits we have to take here. Okay, this is inside this loop, area of the, and this is the loop given here, r square equal to a square cos 2 theta. This we have converted into polar coordinates. Okay, so now this is the formula given. Therefore, finally, equation is, I mean limits are 0 to pi by 4 for theta, and for r 0 to this one, r put 0, then okay, r equal to 0 to, if I put 0 here, or cos 2 theta equal to, in the situation when r is 0, this is r square equal to x square by square, or r square equal to a square to cos theta sin 2 theta, or cos 2 theta here. So r equal to 0 to first 0, then r equal to under root of this whole, that means a under root cos 2 theta, that we have taken. Okay, so first when we substitute 0, then we find out the limits, that was pi by 4 plus minus pi by 4. Okay, so these are, now let me integrate this. So this is r upon, or let me take a outside, this is theta equal to 0 to pi by 4 here. Okay, and this is 0 to a under root cos 2 theta. Now this is nothing but r upon under root a square minus r square into dr whole d theta. First we have to integrate this with respect to r here. So what is the limit? Let me just find out. Of putting here a square minus r square equal to t, let me take again. Okay. If I put here r equal to this, that means r equal to this value in the lower limit. So we have taken this, we are putting here a square minus r square equal to t, or minus 2r into dr equal to dt, or r dr equal to minus dt upon 2. Now minus limit is given, we can take negative sign outside, doesn't matter. Minus sign here, this is minus a upon 2. Okay, and limits, now if I substitute limits, this a first is 0, r equal to 0, then t equal to a square, and when r equal to this a square cos 2 theta under root cos 2 theta, this a square cos 2 theta, it will be a square common, so 1 minus cos 2 theta. That means t is equal to, this is a square, or yeah, a square cos 2 theta, or if I take this above the, okay, I mean in the numerator, if I take, so a square minus r square whole power minus half, that will be, okay, then integration will be, or if I not convert the limits, then first integrate, then putting the value of that, and then substitute the limits, simple. Let me first integrate this, not changing the limits here, not to change limit, let me first integrate. It will be 1 upon under root t, that means t raised power, this is okay, theta equal to, so 0 here, first is theta equal to 0 to pi by 4, and here theta r equal to 0 to a under root cos 2 theta, no problem. Now here t raised power minus half into dt, so what integration will be? Integration of this will be t raised power plus half upon half, that means 1.2 to cancel out, so this will be nothing but a minus sign can be neglected. Minus a upon 2 into 2 upon 1. Okay, this is 0 to pi by 4 here. Now this is t raised power half. T raised power half, positive half. That means under root t only. This is integration. After that we have to put the value of t. Under root t means under root of this a square minus r square. It will be under root a square minus r square. Then limits are substituted. Let me write here. So answer we are calculating as area is equal to minus a. Now 2 to cancel out, because this 2 to cancel out. Minus a, limits are here, theta equal to 0 to pi by 4. And here r equal to, here 0 we are substituting, 0. R equal to 0 to minus half. No problem. Then 0 to pi by 4 here. And under root t is there. Under root t means under root a square minus r square, but limits we have to apply 0 to a under root cos 2 theta. R is equal to. Okay. And then d theta. First apply the limits. Limits. Now we have converted this t into further the same thing. It will give us minus a theta equal to 0 to pi by 4. Okay, now here it is under root. First point is a square minus a square cos 2 theta. That means a 1 minus cos 2 theta, it will be minus sign. R is 0, it is only a. Okay, into d theta. It is nothing but this is minus a theta equal to 0 to pi by 4. A, let me take outside, this is a square now. A is outside now. 1 minus cos 2 theta is 2 sin square theta by 2. So 1 under root 2. It is sin square. So it will be sin only half. That means sin. But this is sin theta here. 1 minus cos 2 theta. It is only sin theta. Sin square, it will be sin square theta, 2 sin square theta. This is under root 2 sin theta only. Minus a into theta. Okay. Now we have to integrate this. This is a only. A we have taken outside. This is 1 only. Now this is d theta. Got the point? Why? A we have taken common, so this is only under root 1 minus cos 2 theta. And root 1 minus cos 2 theta is 2 sin square theta. So this is under root 2, because square root is to be taken out. So this is sin theta only. Minus 1, because a we have taken outside. Now we have to integrate this with respect to theta. That will be the final answer. Let me now put. After putting the limits in terms of r, we have taken these limits. We didn't change the limits. We have first converted that into t. Then t is back. Okay, change into r again. Then we substitute the limits. That can be done. Just use the question. Now this is minus a square. Limits minus sign can be, because area is always positive, so minus sign can be neglected. But let me first integrate this. So this will be integration under root 2 as it is. Sin theta is minus cos theta. That means negative cos theta here, minus theta, minus plus here. Now limits are 0 to pi by 4. Substituting this, it will give us a square now positive. Cos pi 4 is 1 upon root 2. Now into root 2. And this is plus now, because minus sign we have taken common. This is pi by 4. Then put the minus sign here. When we put the lower limit, it will be only under root 2. Because cos 0 is 1. It will be minus under root 2. And then this is 0 here. Theta is 0. Only minus 2. The final value is 1 minus root 2. It is a square, therefore. Okay, pi by 4 plus 1 minus, this is 1 here, root 2. This is the answer here. Area is a square into this numerical value is there. Okay, this is the area of the surface, question number 2. Answer here, question number 2 we have done now. Now Let's take the next question, question number 3. What does question number 3 say? Let me now check it. Now question number 3, what does it say? Question number 3 is, here it is. Question number 3 is this. It says find the area of the surface z square equal to 2xy, included between the planes x equal to 0, x equal to a, and y equal to 0 and y equal to b. Here limits for x and y both are given, so there is no need of converting them into polar coordinates or parametric form, nothing. Not to change it into parametric form or polar form. We can do this in Cartesian form as well, because limits are given for Cartesian form. Okay then. So let us take question number 3 now. Question number 3 says that z square equal to the curve is twice xy. This is the first equation. Okay, limits are given, included between planes x equal to 0, x equal to a, and y equal to 0 and y equal to b. So limits are given for x and y. No need of them converting them into polar coordinates. Okay, now let me find the area for this equation. In this case, for the area here, differentiating first with respect to x and y partially respectively. Means first with respect to x, then with respect to y. That means respectively mean. Okay. So that means, let me integrate this now. So twice z into del z upon del x, first x with respect to x. It is now 2 into y only, constant value. That means del z upon del x equal to y upon z. This is first, second equation that we take. Now for third one, if I find del z upon del y, it will give us 2x upon 2z. That means x upon z here. Similarly, if I differentiate it, similarly, this 2z into dz upon delta z upon del x, the del y equal to twice x, only y is 1. Okay, twice x then considered as constant. So it is twice x upon twice z, that means x upon z. Therefore, this is, let me take third one. Therefore, okay, second alpha is equal to under root 1 plus del z upon del x whole square plus del z upon del y whole square. That means under root, this is 1 plus y square upon z square plus x square upon z square. This will give us under root x square plus y square plus z square upon z square. What is the value of here? Z square is twice xy. That will give us under root, this is nothing but x square plus y square plus twice xy, so z square equal to divided by twice xy. It will give us, in the numerator we have x plus y whole square. It is x plus y whole square, square root of this upon twice xy. That means this is nothing but x plus y upon under root 2xy. This is the value of second term. Therefore, area, let me find out. Therefore, area of the surface. Therefore, area of the surface of the given curve. Question says surface included between this. Okay, required area of the surface is equal to, now integration. Now x we are taking limits from 0 to, we are given 0 to a, and y is given, y is given here 0 to b. No problem. Now x and y we are taking note of. This is x plus y, second alpha is upon under root twice x by into dx dy. Now let me do this again. Do this further. Integrating it further, what we get here? In this case, we will get now first let me convert this. This is x equal to 0 to a, y 0 to b. We are given. Now this is x upon 1 upon root 2. Let me take outside. Now it will be x upon under root x into under root y. It will be then under root x upon under root y. Why? Because x means under root x into under root x. 1 under root x cancel out is square root. This x means x can be written as square root x into square root x. 1 square root x is cancelled out because x square root x means 1 upon 2 power, half power. And this x is having 1 power. So 1 power upon half power of x will be x raised power half only, divided by y raised power half, plus second part. This is under root y upon under root x into dx dy. First integrating with respect to y. Okay, so this will give us 1 upon root 2, 0 to a, let me put as it is, integrating it with respect to y first. Okay, then applying the limit 0 to b. But before that, this is y now. Under root x is constant we have taken. 1 upon under root y means y raised power minus half. It will be integrated as y raised power plus half upon plus half. Integrated plus under root y 1 upon root x as it is constant. Y is integrated as y raised power 3 by 2 upon 3 by 2. Limits 0 to b. This is dx now. So this is what 1 upon root 2, limits now 0 to a. This is twice into a root x into root y. This is plus here we are having y root y 2 by 3. This is 2 by 3 here. Y root, because y raised power 3 by 2 means y square root y into x raised power half or x square root x here. Okay, so under root x we can take outside. This whole is, then we have to substitute for limits. We have not substituted yet. I'm sorry. Still we have to put the limit 0 to b. We have not applied the limits b in place of under root y. That I have to substitute a step into dx then. So limits, let me substitute here 1 upon under root 2. First b at 0 it will be 0. So b only. So in place of y we have to substitute limit b. This is under root b. So it will give us 0 to a. It is nothing but twice under root b into under root x as it is. That's 2 by 3. Y means b under root b. It is into under root x as it is. It means square root x. I'm sorry, this is upon square root, or x raised power half it is. It is x raised power minus half. Minus half here. Okay, this is x raised power minus half, I'm sorry. This is minus half power because this is in the denominator, 1 upon under root x. 2 by 3 y raised power 3 by 2. That is this 2 by 3 b under root b. Alright. So now we have to integrate this whole with respect to x. That will give us the answer. Let me now do it here. Okay, so finally area will be therefore area is equal to or s equal to a is equal to or s equal to area s is equal to 1 upon root 2. Now if I integrate under root x, it is 2 under root b x to the power 3 by 2 upon 3 by 2 plus 2 by 3 second point b under root b into x to the power minus half integrated as x to the power half plus upon half limits 0 to a. Let me now substitute the limit. If I put x, limits of x at a 0 to a means only at a limit will be there, because at 0 everything will be 0, because x multiplied to this will be 0, because if I put 0 here it is 4 by 3 1 upon root 2 as it is, in bracket it is 4 by 3 now under root b into x to the power 3 by, that means a under root b now, under root a under root ab plus, this is now 4 by 3 this is also b under root b, and this is under root a here, so under root b under root ab, because under root a into under root b means under root ab. This is the answer here. If I take 4 by 3 out and under root ab also out, it is 4 by 3 root 2, 4 by 3 root 2, or I'll just write 2 root 2 upon 3. Let me first write it as under root ab common, it will be now a plus b in the bracket. It is now under root 2. If I multiply in the numerator, rationalizing, it will give us under root 2 divided by 2 means 2 root 2 upon 3 into a into b under root, or let me write a plus b here into under root ab. A plus b I have written down first. Happy to prove this or just find out the answer? Okay, answer is this: 2 root 2 upon 3 into a plus b under root ab, or under root ab into bracket a plus b. This is the answer here. Question number 3 we have now completed. But the question number 4, let me talk about it. Now question number 4, what does it say? Now question number 4 is, okay, question number 4 says, let me check it. Now it says, find the area of the surface of the sphere x square plus y square z square equal to a square included within the cylinder x square plus y square equal to ax. Okay, here question number 4. What is the